This is toolmaker's microscope. Using this one, we can measure the angle of cutting tools that can be used on lathe. So there are different angles for cutting tools, HSS cutting tools. Depending upon the materials, you have to grind the tool angles, and that angles we can check here. This is called a toolmaker's microscope. This is a cutting tool. We can on this table we can place our cutting tool and focus. This is the sighting microscope and vertical column, and here is a lock. On releasing the lock, you can move this up and down like this. Lock this and through this sighting microscope we can see the image. Illuminated from the back side. From there, that falls on to a reflector here at the bottom of the here. From there, it is projected to the sighting microscope. So the image we can see through the sighting microscope. This is the angular eyepiece. This is called a goniometer. Here, this is 0 to 360 degree. When 0 to 360 degree, we can measure. And least count is 60 degree. 1 degree is divided into 60 minutes. So you can see degree in degree and the corresponding vernier scale having 60 division. So each division having 1 minute. So through this we can see reference line. Reference line. Reference line is like this. You can rotate the reference line. This you can rotate by adjusting this knob. This knob, by rotating this, you can adjust the reference line. These are vertical hair lines. Vertical hair lines. This is horizontal hair lines. So corresponding to this rotation, you can see the angle through this goniometer, and we can move the table in the y direction by this rotating this micrometer. This range is 0 to 25 mm. One division's least count is 0.001 mm. Here also same type of scale, 0 to 25 mm range is 0 to 25 mm. And we can rotate this table also by this knob. Rotate there, so this will rotate. Corresponding angular reading we can see here. On the side, angular reading is there. So first we can see what are the angles. There are 6 angles and 1 nose radius. So there is a specific sequence for specifying the angle, different angles, 6 angles and nose radius. That is called tool nomenclature. First number is this one, back rake angle. Back rake angle, this is the rake surface. This is back rake. This is inclined towards the shank. It is back rake angle. Then side rake angle. This side is inclined toward the side. This side, it is side rake angle. Then this is the cutting face is here. Yeah, this is end face. This is the cutting face. So this is having back rake, side rake. This edge is the cutting edge. This angle is side cutting edge angle. This is cutting edge. This angle is side cutting edge angle. Then the face is inclined downwards. On the vertical plane, this face is inclined downwards. That inclination is side relief angle. This is side relief angle. So this back rake, side cutting edge angle, side relief angle. Then this is the end face. End face with horizontal axis. This angle is end cutting edge angle. And this end face is inclined downwards. From the vertical axis, it is inclined downwards. So you can see this end face is inclined. This inclination. This is end relief angle. So end cutting edge angle, end relief angle. Back rake angle. To this inclination is side rake angle, side cutting edge angle, side relief angle, end cutting edge angle, end relief angle. You can see so this is the nomenclature, tool signature, tool nomenclature or tool signature. Some numbers you can see sequence of numbers here. First number is back rake angle. This is back rake angle. Then side rake angle. Then end relief angle. End relief angle. Then side relief angle. Then end cutting edge angle. Side cutting edge angle. This one is nose radius. So we can measure all these 6 angles and the nose radius. So this using TM you can measure 3 angles directly. That is end cutting edge angle, side cutting edge angle, and end relief angle, end relief angle, end cutting edge angle, side cutting edge angle. This we can directly measure because that image directly we can see. But the back rake angle and side rake angle, we have to use projection method. You can mount the tool along the axis, and using a dial gauge we can measure the slanted height on the top of the surface. You can fix this on the table. Then this is to get the back rake angle. You have to measure the slanted height of this one. Then that you get from the dial gauge that we can set there. Then move the tool and get the standard height. Then this displacement you can note from the micrometer. So this height and the displacement you can get. So from that you can calculate the back rake angle. Similarly for side rake angle, use other micrometer to see what is the side rake angle, and also side relief angle. Side relief, these 3, and back rake, side rake, and side relief. You have to use projection method to find out the angle. So now we can start measurement. We just place the tool here. Then focus, release this lock. This for this rotating the to adjust the hair lines, reference lines. adjust the X micrometer. Angular position. This is for fine adjustment. This one is for fine adjustment. Small adjustment is fine adjustments, fine focusing. See, for this one, for tool, this is not required. If a very small, minute particle, then you can go for fine adjustment also. With the coarse adjustment, you cannot at once you cannot focus. So you use fine adjustment for focusing. In the case of a very small, tiny particles. So now I adjusted the position of the tool like this. You can see here like this, but like this. But now you can see only this edge only. This edge, the full tool we cannot like this. We cannot see. This only representation. So I focused only a small portion of the tool, this side, just beneath the cutting edge. So this one you can see the image. So you can see the edge of the tool shank, and also the center dotted line coinciding along that edge. Not the corresponding angular reading from this angular scale. Here is angular scale. Angular reading is initial reading, and when the reference line coincides along the left side of the tool shank, it is 172 degree 34 minutes. And just note down the reading. Now what you do is you have to, so like this, you are getting the reading 172 degree 34 minutes. Now you have to tilt the same line to this side, cutting edge, along the cutting edge. So again you note that reading. The difference is the side cutting edge angle, this angle, side cutting edge angle. So we can adjust, move the micrometer, y-axis micrometer. Then adjust x-axis micrometer. Then adjust the reference line so that this line coincides with the cutting edge. So now this reference line coincides like this along the cutting edge, and again note the reading from the angular scale. This is 142 degree 48 minutes. 152 degree 48 minutes. 152 degree 48 minutes. That is the final reading. So difference of these two readings, you will get the side cutting edge angle. So I focused this along the middle side of the edge. So you cannot see the tool tip. This at the middle. So only an inclined line you can see, dark inclined line, that is along the cutting edge. Now you can see the angular reading. So the reading is 152 degree 48 minutes. So we find out the difference, that is the side cutting edge angle. Now for end cutting edge angle, initially for end cutting edge angle is this angle, this horizontal axis, and this cutting edge this cut end face. That difference is the end cutting edge angle. So initially you have to adjust the first reference line along the cutting this side of the shank, as in the previous case, as we measured in side cutting edge angle. So we can take the initial reading, the same initial reading for end cutting edge angle. So initial reading for side cutting edge angle is this one, 172 degree 34 minutes. But for coinciding with this one, you have to coincide this horizontal line, this single dotted line along this edge, end face edge. So that difference we will get end cutting edge angle. So now I am going to adjust. So now the problem is at that time we cannot get it. So now I am only getting halfway only. This is at the extreme position of the micrometer. So I have to reposition the tool. So move this to the first was initial position. We can take start from the beginning. So I could coincide the horizontal line like this center dotted line like this. Then note the reading, angular reading 178 degree 34 minute, 178 degree 34 minute, 178 degree 34 minute initial reading. Now bring this cutting edge. End face edge. So since this edge is inclined, this cutting edge is inclined, when we are moving along the x-axis, it will go away from the sighting field. So we have to adjust the x micrometer so that we can see. Now I am adjusting this single dotted line to this end face edge by touching this knob. So I adjusted like this, and angular reading also can take 142 degree 30 minutes. 142 degree 30 minutes. This is the initial reading, final reading. That difference is end cutting edge angle. Left side like inner reference line കാണോ. So the angular value is 142 degree 30 minutes. So side cutting edge angle is 90 degree 46 minutes. End cutting edge angle 178 degree 34, 142 degree 30. So difference 4 minutes 6, 36 degree, 36 degree 4 minute. So this is end cutting edge angle. Now similarly we can go for end relief angle. For end relief angle, you have to keep the tool like this. This, you can say this is the end relief angle. This is the end relief angle. So you have to keep the tool like this. Like this. This is back rake, end relief. End relief. So this is the projection of this one. Side rake, side rake, side relief. This is third angle projection. So this side rake angle. This angle is side rake angle. This angle is side relief angle. Side rake means when we hold like this top face is inclined to this side. That is this one. Side rake. This one side rake, and then face side face is inclined downwards. That is this. So from the vertical axis it is inclined. That is the side relief. This is the top face. That is inclined. That is side rake. This is also top face inclined towards the shank. That is the back rake. Now we have to go for this end relief angle. So keep the tool like this here. So again we have to start. So initially adjusted and the angle initially adjusted along the edge, then initial angle is 178 degree 7 minute. 178 degree 7 minute. 178 degree 7 minute. So then angular reading is 178 degree 7 minute. Angular reading is 178 degree 7 minute. You can see this upper reading is in degree, that is 178. Then 7th division is coinciding. That is why that much minute. 178 degree 7 minute. Now you can move this to the then we can bring the cutting edge in the field. After focusing, you lock this one, take the hand, then adjust the single dotted line, that is the horizontal line, coincide along the edge, end face edge. Now note the reading, it is 198 degree 51 minute, 196 degree 51 minute. 196 is upper one, reading in 196, and the coinciding division is shown 51th. So 196 degree 51 minutes. 44 minutes. So end relief angle is 18 degree 44 minutes. And cutting edge angle 36 degree 4 minutes. So these three angles we can directly measure. Now other three angles, back rake, side rake and side relief. We have to use one more dial indicator, so that we will get the inclined height of the surface and the corresponding horizontal movement we can note from the microscope. So we can adjust for that. So this is the setting for back rake angle, side rake angle and side relief angle. Now we can measure side rake angle, this like this. So the procedure is, you can see here, side rake is inclination angle towards the shank, like this. So what we are going to do is, this is tool is mounted along the axis, x-axis. So for that purpose we adjust the circular scale here at 90 degree here, 0 degree, not 0 or any quadrant. Now it is 90 degree, okay, 90 degree, here it is 90 degree here. So this is along the axis of the instrument. Along the axis we mounted the tool on a stand. Now we can use dial gauge for the inclination height. For measuring inclination height, you can use dial gauge. So this is mounted on a universal vise, hydraulic universal vise. We can mount anywhere. So adjust this on the top face of the surface. Just touch this. Initially it is, you are just direct to 0. Now this dial is set to 0. Now set the dial gauge on the plunger on the top surface. Top surface. Now again set this to 0. Now you can move this. Now here also our micrometer is also set to a constant reading. Now this is 10.00, I already set here. 10.00. This is top point is set to 00. Now I can move this by 5 mm. 5 mm. And problem is this coming out. Set this to again. So since that edge is inclined, this is coming out. So you adjust here. Okay. Now set the reading. Take the reading here. This 0.01. You can set to 0. Now move this to 5 mm. This is 15.0, 0.1, 0.1, 0.10 initial reading, 0.10. Now move this to OMO. Now this is 15 here. So what is the reading here? Here is 1.1.20, 1.20, 1.20, previously 0.10 minus 0.10, so 1.10 mm. So this inclination height is 1.10 mm, like this. Here 1.10 mm, this is 5 mm. So you can calculate this angle, back right angle. Similarly, you can measure side right angle. For side right angle, you can move to on this micrometer. Then, as in the previous case, you can find out the inclination height, and you can calculate side right curves. For side relief and this top inclination, side inclination, you can keep like this way is vertical, and also you can use the X micrometer to find out the inclination on this surface, so that you can calculate side relief angle. So this way you can find out 6 angles. Now one more value is there, that is nose radius. So we are already measured these 6 angles: back right angle, side right angle, end relief angle, side relief angle, end cutting edge angle, side cutting edge angle. Now one is remaining, nose radius. This tip always having a roundness, so that one also we can measure. For that, another ocular we can use. Remove this one. This ocular is used for measuring nose radius. This is having so many concentric circles you can see, and corresponding angle is also radius is also written on the side of that circle. So you can select the circle that is matching with the tip, that you can change by rotating this knob. So this, we already set this circle to the tip of the point. You can see 0.2, 0.4, 0.6 circle, concentric circles on this of this 0.2 mm coincide. 0.2 mm radius circle coincide with the tip of the tool. You can see 0.2, 0.4, 0.6 circles are there, and on that 0.2 circle is matching with the tip. So that is the radius. If you want to check another, then you can use this knob to change that circle. So these are all the measurement. We already measured the values specified in the tool nomenclature. 6 angles and 1 nose radius.